Dear Class 10 students, welcome to Chapter 3, Pair of Linear Equations in Two Variables. You have studied in Chapter 2 the linear polynomial. You know the examples of linear polynomial. 3x plus 4 is a linear polynomial. 5x minus 8y is a linear polynomial. When there is an equal to sign and an LHS and RHS, it will become a linear equation. Suppose 3x plus 4, equating this to another linear expression, that is 5z. Then 3x plus 4 equals 5z is a linear equation. 5x minus 8y is a linear polynomial. When I equate this linear polynomial with another linear polynomial or any constant, 7. So 5x minus 8y is a linear equation. So a linear equation means any equation with the degree of the variable is 1. The exponent of the variable is 1. Now linear equation in one variable. When the linear equation has only one variable, example 3x plus 4 equals 8. So it is an equation, it is a linear equation because the power of x, the variable is 1. So it is a linear equation. Now another examples are 8y plus 6 equals 9 is a linear equation in one variable. Here the variable is y. Now you have studied in class 8 and class 7 and class 8 how to find the values of this x and y for a linear equation in one variable. One example, 8x plus 4 equals 20. The question will be asked like this: solve 8x plus 4 equals 20. That means you need to find the value of x so that the LHS and RHS are equal. So you need to substitute a value for this x so that this complete LHS and this RHS part are equal. Now you know how to solve it. So here the solution is 8x equals 20 minus 4, that is 16. X equals 16 divided by 8 equals 2. So x equals 2 is a solution for this equation, linear equation. Now linear equation two variables. Whenever a linear equation contains two unknowns, two variables, it is called linear equation in two variables. The general form of a linear equation two variable is ax plus by equals c. So there will be an x term and y term. This a, b, c are the constant, and with a condition that a and b both should not be equal to 0. A comma b both not equal to 0. Examples for linear equation two variables are 3x plus 4y equals 12. And you have studied in class 9 about the linear equation two variables and its solutions. I'll give one example: x plus y equals 10. Now the difference between linear equation two variables and linear equation one variable is, for a linear equation one variable you will get only one solution, but for a linear equation two variable, for each value of x you will get a corresponding value for y. That means there are infinitely many solutions. For this case itself, you can see that when x equals 1, then the value of y equals 9. So you will get x plus y, that is 1 plus 9 equals 10. When the value of x equals 2, then the value of y will become 8. So that 2 plus 8 equals 10. When the value of x equals 1.5, then the value of y will become 8.5. So it can take integers, it can take natural numbers, it can take decimals, it can take fractions. There are infinitely many solutions for the equation x plus y equals 10. And in class 9 in the chapter linear equation two variable, we have studied how to represent these solutions in a graph. Now pair of linear equations in two variables. When we consider two linear equations of two variables, then we'll say it is a system of linear equation in two variable or pair of linear equation in two variable. Examples: 3x plus 4y equals 8 as one of the equation, and 8x plus y equals 20 as another equation. When we consider the both equations together, we'll say it is a pair of linear equations in two variable. Here, the general form of the linear equations, a pair of linear equations two variable, is a1x plus b1y equals c1, and a2x plus b2y equals c2, where a1, b1, c1, a2, b2, c2 are constant and x and y are the variables. So the general form of pair of linear equations in two variable is a1x plus b1y equals c1 and a2x plus b2y equals c3. So why we are saying it is pair of linear equation two variable? Because we are taking two linear equation two variables together. Okay. Now here also you can find the solutions of pair of linear equation two variable. That means the values of x and y which satisfy both the equations. So the value of x and y should satisfy the equation number 1 and equation number 2. Such values of x and y are called solution set of linear pair of linear equations in two variables. There are two different methods to find the solutions of the linear equation two variable. The first method is graphical method, and the second method is algebraic method. In algebraic method, there are three different methods. One is substitution method, then cross multiplication method, then elimination method. We can see in detail how to use graphical method to find the solution of the pair of linear equation two variables, and what are the different cases in graphical method. Now let's see graphical method in detail. What are the different cases in graphical method? The first example is x plus 3y equals 8. You have studied in class 9 how to find the solution of a linear equation two variable and how to draw the graph of linear equation two variable. So we need to find minimum 3 or 4 pair of solutions. Here I am rewriting this equation as x equals 8 minus 3y, so that I can solve it easily. Now I'll draw a box x, y. I will substitute the values for y so that I will get the values of x. I am substituting y equals 0 so that x value is 8. I am substituting y equals 1 so that x equals 5. I am substituting y equals 2 so that x equals 2. Now I got three pair of solutions, three solution sets. Okay, now I am marking these points on the graph. First one is x is 8, y equals 0. So x is 8, y equals 0. The point is here. And second one, x is 5, y equals 1. X is 5, y equals 1 is here. And 2 comma 2. 2 comma 2, the point is here. So the graph through this point is this one. Okay. Now the next pair of the linear equation. So we have pair of linear equation. So the second pair is 2x minus y equals 9. So here I will rewrite the equation as y equals 2x minus 9. Here I am substituting values for x. So for that I will make a box first, x, y. I will substitute x equals 2 so that I will get y equals minus 5. I will substitute x equals 3 so that y equals minus 3. I'll substitute x equals 4 and y equals minus 1. Now I'll mark these points on the graph. First one is x2 and y minus 5. x2, y minus 5, the point is here. And 3 comma minus 3, 3 comma minus 3, the point is here. And 4 comma minus 1, 4 comma minus 1, the point is here. Okay. Now the graph through this point is like this. Okay. Now in this case you can see that the graph is an intersecting graph. Intersecting graph. when the graph is an intersecting graph, the intersecting point, this is the intersecting point, the point is 5 comma 1. That means x equals 5 and y equals 1 is a solution of the pair of linear equations. What is the pair of linear equation here? The pair of linear equation here, x plus 3y equals 8, that is this one, and 2x minus y equals 9. For both the equations, x equals 5 and y equals 1 is the solution. If you substitute x equals 5 and y equals 1 in both equations, the LHS and RHS will be same. Now let's check the second case. The example here is 3x plus 2y equals 1. So here also we need to find the solutions to draw the graph. So I'm marking a box here, x, y. After solving, we'll get when x equals 1, you will get the y value is negative 1. When x equals 3, the y value is negative 4. When x equals 5, the y value is negative 7. Now you can mark these points on the graph paper. So when x equals 1, y equals negative 1, the point is here. When x equals 3, y equals negative 4, the point is here. When x equals 5, y equals negative 7, the point is here, right? So the graph through this point will be like this. Now the next pair of equation for this example is 3x plus 2y equals 8. Here also we'll find three set of solutions to draw the graph x, y. So we'll substitute x value equals 0 so that y value is 4. We'll substitute x value is 2 so that y value is 1. We'll substitute x value is 4 so that y value is negative 2. Now I'm marking these points on the graph sheet, on the same graph sheet, okay? Don't take different graph sheet for pair of linear equation. You need to plot both the graph on the same sheet. So here 0 x 0 y 4, x 0 y 4, the point is here, and x2 y1, 2 comma 1, 2 comma 1, the point is here, and 4 comma minus 2, 4 comma minus 2, the point is here. So the line of graph through these 3 points is like this. You can see here the graph is a parallel graph. Parallel graph. That means there is no intersecting point. The lines are not intersecting. The intersecting point is the solution of the linear pair of linear equation. Since here there is no intersecting point, there is no solution for this pair of linear equation in two variables. Okay. Now the third case. Here it is x plus y equals 5, x, y. So when x equals 0, y value is 5. When y value is 0, x value is 5. When x value is 1, y value is 4. Now I'm going to mark these points on the graph. So x is 0, y is 5. The point is 3, 4, 5 here. And x5, y0. x5, y0. At 5, comma 0, the point is here. And 1, comma 4. 1, comma 4, the point is here. So the line of graph through these 3 points will be like this. Now the next pair, 2x plus 2y equals 10. So here also we'll find 3 set of solutions, x, y. When x is 2, you can see that y equals 3. When x is 3, y equals 2. When x is 4, y equals 1. So I'll mark these points on the graph. 2, 3 is here. 3, 2 is here. And 4, 1 is here. So the line is the same line. X plus y equals 5 and 2x plus 2y equals 10 both represent same line, or the lines are coincident. Here the lines are coincident. Every points on the first line are the points on the second line. That means there are infinitely many solutions. So in all the three cases, we got three different types of graphs and three different types of solutions. Let's check all the three cases together. So the first case was x plus 3y equals 8 and 2x minus y equals 9. And we got the graph is an intersecting graph, right? It is an intersecting graph. Intersecting graph. Now, without drawing the graph, there is a method to find out whether the graph of the given pair of linear equation is intersecting or parallel or coinciding. We know that the general form of the pair of linear equation is a1x plus b1y equals c1 and a2x plus b2y equals c2. C1 and C2. Okay. Now when considering this a1x plus b1y equals c1, a2x plus b2y equals c2 with a x plus 3y equals 8 and 2x minus y equals 9, you can see that a1 equals 1, b1 equals 3 and c1 equals 8, a2 equals 2, b2 equals minus 1 and c2 equals 9. So we'll find the ratio of each one. So a1 by a2. Here a1 by a2 equals 1 divided by 2. And b1 by b2. b1 by b2 equals 3 divided by negative 1. They are not equal. So you can see that whenever the graph is an intersecting, always a1 by a2 is not equal to b1 by b2. Or we can say when a1 by a2 is not equal to b1 by b2, the graph will be intersecting and you will get a unique solution for the pair of linear equation. I'll repeat, when the coefficient a1 by a2 is not equal to b1 by b2 for the given pair of linear equation two variables, the graph of the pair of linear equation will be intersecting graph and it will have unique solution. That means one value for x and one value for y. Clear? Now the second case. So here we'll find out what is a1 by a2. So a1 by a2, a1 by a2. So this is the a1 value, this is the a2 value. So a1 by a2 is 3 divided by 3, that is 1. Now we'll find b1 divided by b2, and b1 by b2 is this value is b1 and this is b2. So 2 divided by 2, that is 1. They are equal. Now we'll check what is c1 by c2. c1 by c2 is, this is c1 and this is c2. So it is 1 divided by 8. So it is not equal to 1. That means in this case you can see that a1 by a2 is equal to b1 by b2 is not equal to c1 by c2. So when a1 by a2 is equal to b1 by b2 and not equal to c1 by c2, without drawing the graph, you can conclude that the graph of the given pair of linear equation will be always parallel and there is no solution for such a graph or such equations. Okay. Now the third case, x plus y equals 5 and 2x plus 2y equals 10. So here a1 by a2 equals 1 upon 2, 1 divided by 2, and b1 by b2 equals 1 divided by 2 again. So this is the coefficient of x will be 1 here, the coefficient of y will be 1. So this is a1 is 1, b1 is 1. Now c1 divided by c2, there are the constants, so 5 divided by 10. So 5 divided by 10, you can cancel, divide both the numerator and denominator by 5. So you'll get 1 divided by 2. That means A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay, so when A1 by A2 equals B1 by B2 equals C1 by C2, the graph of the such pair of linear equation will be coincident graph. Coincident. The previous one is parallel. Okay, in this case there are infinitely many solutions. So the first case there is unique solution. In the second case no solution, and here infinitely many solution. Infinite solutions. To sum up, you can see the table here. So ratio of the coefficients is given. When A1 by A2 is equal to B1 by B2, the geometric representation is intersecting lines and algebraic interpretation. So they are the solution, exactly one solution or unique solution. And when there is solution, the word used it is consistent. Consistent means there is solution. So whenever the pair of linear equation has solutions, so it is a consistent pair of linear equation. And the second one, A1 by A2 equals B1 by B2 equals C1 by C2. In this case, the geometrical meaning is the graph will be coincident lines, and the algebraic, about the solution, there will be infinitely many solutions, and it is consistent because there is solution. Now next case is A1 by A2 equal to B1 by B2 not equal to C1 by C2. The geometric representation is parallel lines and algebraic interpretation. That means regarding the solution, there is no solution, and since there is no solution, it is inconsistent. Thank you for watching. Stay safe.